As you can see, this is the homework for derivatives of inverse functions. And the keys to your success, if I flip back in the flip chart a page, oops, not there. The key to success, two keys. If you're smart, make a chart. And the other one is partner points on inverse functions have reciprocal. Reciprocal just means flip it. Slopes. So be careful not to mix that up with perpendicular lines. I hate to even say that. Problem number one. Let f be the function defined by f of x equal x cubed plus x. G of x is equal to f inverse. So I'm going to begin over here with starting my, if you're smart, make a chart. So I have a function named f and I have a function named g, which is equal to f inverse. On the g function, I have a point which is 2, 1. Therefore, I know on the inverse there is a point 1, 2. I want the derivative of g at 2. Right? So I don't really want to create the g function. So I did my smart chart. If you're smart, make a chart. And now I'm going to use my other fact, partner points. So 1, 2, and 2, 1 they are the partner points on inverse functions have reciprocal slopes. So remember, I do know the function f, specifically x cubed plus x. So I'm going to find the derivative of that function, which is 3x squared plus 1. I'm going to evaluate it at the x for f. Remember, I want the derivative of g at 2. So over here, I ultimately want g prime of 2, but I'm going to use the inverse function to figure it out. So f prime of 1 is equal to 3 times 1 squared. So that's going to be 3 plus the 1 is 4. So that's the derivative on the original function. Partner points on inverse functions have reciprocal, there it is, slopes. So if the slope on the partner at the partner point on the original is f, the slope on the inverse at the partner is 1/4. So it's easy to come up with that slope. Problem number 2. Let f be a differential function. I think it's supposed to be differentiable function such that f of 3 is 15, f of 6 is 3, and then I have the derivative about information about the derivatives at those x values. The function g is differentiable and g of x is the inverse. So I'm going to come over here. Well, I'll stay on the right hand side. So number 2, I have two functions. I'm going to make a smart chart because if you're smart, make a chart. So we know that g is the other function, which is the inverse of f. Let's see. What do we ultimately want to find? G prime of 3. So 3 is the x value of g, meaning that 3 is on the partner is the y value of f. So I'm going to go and look for a y value. So that's why they're giving me extra information. This is the point that I need to focus on. So since 3 is the y value of f, the x is 6, and on the partner, the y is 6. Again, I'm looking for g prime of 3. So I'm going to use the partner function. Over here, I know that f prime of 6 right here is -2. Partner points on inverse functions have reciprocal slopes. So then, therefore, the partner would have a slope of -1/2. Remember, we're only flipping the fraction. We're not changing the sign. Number 3. I'll come over here on the left-hand side for number 3. Find the value of g prime of 1 when g is the inverse of f. So they're kind of setting us up the same way again. I have f, I have g, and g is the inverse of f. I want to find g prime of 1, so that 1 is an x value of the g function, and therefore the 1 is a y value on the f function. All right, so I need an x value to go along with that, which I don't have. So I'm going to need to figure out where the f function, so 2 sine x equals to 1. In other words, this is a y value for the f function, so I need to solve to get the corresponding x value. So I'm going to divide both sides by 2. I also need to pay attention to, over here it's telling me, because there are infinite angles that have a sine of 1/2, I want the angle that is between negative pi over 2, so negative pi over 2 is down here, and pi over 2 is here. So I'm searching in either quadrant 1 or what I would call negative quadrant 4. Now, since the sign is positive, the y value is positive, it tells me I have to come out of the angle has to come out of the first quadrant. So then when we think about our 30, our 45, and our 60 angles, or our pi over, which would be the same thing as pi over 6, pi over 4, pi over 3, I want the y value, I want the sine to be 1/2. So that's going to send me to 30 degrees because the cosine of 30 degrees is root 3 over 2 and the sine is 1/2. So the x value that I'm looking for is pi over 6. I'm going to substitute that there. And if that's the x value on the original, it's the y value on the inverse. Those are my partner points. Now, remember my goal was to find ultimately g prime of 1, but I don't have g, so I'm going to use f. So the derivative of the f function, the derivative of 2 sine x, is 2 cosine x. I'm going to evaluate that at the x value of f, so that's 2 cosine of pi over 6. We said the cosine of pi over 6 is root 3 over 2. The 2's divide out, and I get root 3 as the derivative on f at pi over 6. Partner points on inverse functions have reciprocal slopes. So the reciprocal of the square root of 3 is 1 over the square root of 3, and you don't have to rationalize that denominator. All right, let's see where we are. That's number 3. I'm going to clear the screen and go to number 4 on the left-hand side. Clear annotations. Number 4, clear annotations. Did it? Okay, we're for a response. Okay, there we go. Problem number 4. Suppose that g is the inverse of a differentiable function f. Ooh, and now we have a third function, so be careful here. We have a little g function, we have a little f function, and those are inverses of each other, and then we have a big G function, which is defined to be 1 over little g. So g of x, this might be helpful at some point, is little g raised to the negative 1 power. I'm just rewriting that in case I need it. Then they tell me some information about little f prime, and they want me to find big G prime of 7. So the goal is big G prime of 7. Now, here is big G, so I need to find the derivative symbolically, and so it was nice that I wrote that as, took that out of the denominator. I'm going to use the chain rule to get big G prime of x. So I'll get negative 1 little g of x to the negative 2, there's my power rule, chain rule times the derivative of the inside. And you can see that big G prime of x depends on little g prime of x. So I'm going to need little g prime to generate big G prime. I want big G prime of 7, so big G prime of 7 is equal to negative 1, or the opposite of g, substituting 7, to the negative 2 times G prime of 7. That sets up my work. So now I have to use that idea that f and g are inverses of each other, little g. So there's f, there's little g, which is f inverse. Let's see what's going on here. They tell us that we have the point 0.37 on the original function f, which means we have the 0.73 on the inverse g. That works out nicely because now 7 is an x value of g, and I need two things. I need little g of 7, which now I know to be 3, and I need little g prime of 7, which I'm going to have to figure out. F. I also know over here that f prime of 3, that's good, is 1/9. And I know these are partner points. And so partner points on inverse functions have reciprocal slopes. So if the slope on the original is 1/9, then on the partner the slope would be the reciprocal of that, 9. So I can use all that information to go back to big G. So I'm down here. So the opposite of, so we'll begin with g of 7 is 3. Don't just do parentheses there. To the -2, g prime of 7 is 9, that's a parenthesis. I have a negative power, so I'm going to make that -1 over 3 to the +2 times 9. That is -1 over 9 times 9, and the 9's divide out. And so g prime of 7 is equal to -1. All right, I'm going to get rid of that because I got a lot of work on here, so let's go to number 5. As soon as I clear the screen. In number 5, so what's going on here? We have a function, f of x, it's to the 5th power. Nice, we have a composition function going on. Oh, wait a minute, no, they're just trying to tell me something. Let's read, be careful, Jernigan. So f of g of x is equal to x, and g of f of x is equal to x. That is just simply a way of telling me that f and g are inverses of each other. In other words, they undo each other. You'll remember from Algebra 2 that this is how we can prove that two functions are indeed inverses of each other. So for number 5, over here on the right-hand side, I'm going to make a smart chart. Because I want to be smart, I'm going to make a chart. So I have f, and I have g, which is equal to f inverse. I want to find f of 1. All right, well that should be pretty easy. F of 1 is equal to 1 to the 5th power, which is 1, plus 2 times 1 to the 3rd power, which is 2, plus 1 minus 1, just substituting into f of x. So 1, knock out 1, 1 plus 2 is 3, so f of 1 is 3, so I can put that here. And on the inverse, the partner point would be 3, 1. The x's and y's switch places. And then they asked me to find g prime of 3. So we're going to find the derivative of f. F prime of x using the power rule is 5x to the 4th plus 6x squared plus 1, and I'm going to use the x value of the partner. So if I substitute 1 to the 4th is 1 times 5 is 5, 1 squared is 1 times 6 is 6, so 5 and 6 is 11 plus 1 is 12. So the derivative on the partner is 12. Partner points on inverse functions have reciprocal slopes, so the derivative on the partner would be 1/12. Next page, number 6. In number 6, we have a function h of x. It happens to be a combination of a trigonometric function and a linear. We want to find h of 0, so why don't we go ahead and do that right away. That's pretty easy. So number 6, h of 0 would be cosine of 0 plus 3 times 0. The cosine of 0, the x value at 0 is 1, so h of 0 is 1. So that's done. That's A. Part B wants the h inverse, and that's a prime rate, the derivative of the inverse at 1. All right, so I want to be smart, so I'm going to make a chart. So I have h original, H original, and I have H inverse. And on H original, I just established that I have the point 0, 1. So on H inverse, I have the point 1, 0. And this wants the derivative of the inverse at 1. So I'm going to find the derivative of H original, H prime of x. Derivative of cosine is negative sine of x. Derivative of 3x is 3. I'm going to use the x value from H original. So that's the opposite of the sine of 0 plus 3. The sine of 0 is 0, so that simplifies to be a 3. So H prime of 0 is 3. Partner points on inverse functions have reciprocal slopes, so therefore the slope on the partner is 1/3. Number 7, we have a motion problem. Yay! So our motion problem says we have a particle moving along the x-axis. Its position is given by x of arctangent t. Prove that the particle is always moving to the right, analyzing the velocity function. So we're actually going to stop right here, because in the year 2020 I changed things up a little bit, and we have not done the derivative of inverse trig functions yet. So I'm just going to stop and make sure I go back and not assign number 7 to you. All right.